guys, so in this video we are going to be taking the derivative of trigonometric functions. And we will be doing that by graphing them, by looking at their graphs. So let's start with just graphing sine of x. That's going to look like this if you remember from a few videos ago. Okay, and that's a little more than a whole period. That's 2 whole periods of sine of x. Now let's graph its derivative. So over here the derivative looks like it's about 1. Slope is about 1. So plot that. Over here the derivative looks like it's 0. Here it looks like the derivative is negative 1. It's 0 again. Looks like over here it's 1. Here it's 0. It's going to be negative 1 over here. 0. That goes back up to being 1. So we can go and go ahead and graph this. Connect the points. That's beautiful drawing. But this actually looks like the cosine function. The derivative of sine of x is cosine x. Okay, next we can take the second derivative. So that's going to be taking the derivative of this. It will also be the first derivative of cosine. We'll have all that in the table over here. Let's look. Right over here, it looks like the derivative is 0. Down here, the derivative looks like it's around negative 1. Over here, the derivative looks 0, 1. Looks like it's back to 0. And then I don't need to keep on doing multiple periods of it. You will see how it sort of works. Then you could, of course, draw more, but you don't need to carefully graph it all. And so, this, about sine of x, think about if you flip it over the x-axis, this looks like negative sine of x. Wherever sine of x is 1, this is negative 1. Wherever it's negative 1, it's 1. Wherever it's 0, it's 0. So that looks like it's negative sine of x. So next, we can take the third derivative of sine of x. So that is taking the derivative of this function. So it looks like it starts at negative 1, goes up to 0, then it comes up to positive 1, goes back down to 0, negative 1, and the cycle is going to repeat. You can sort of see where I'm getting that. Okay. So this looks like, about flipping cosine, this looks like negative cosine of x. And then finally we can take this derivative. Looks like it's going to be 0 because it's going to go back over there. So the derivative is 0, goes to 1, back to 0, down to negative 1, back up to 0. It's going to repeat. Etc. And this is exactly sine of x. So the fourth derivative of sine of x is itself. So we can have this in the table. 0, 1, 2, 3, 4, and can expand this too. We can go 5, 6, and then you'll see where this pattern is going. Okay, so this is the nth derivative of sine of x and the nth derivative of cosine of x. So the 0th derivative of sine of x, that's just not taking the derivatives. That's going to be sine x. The first derivative, we said that's cosine x. The second derivative is minus sine x. The third derivative is minus cosine x. The fourth derivative is itself, back to sine x. The fifth derivative, that's the derivative of the fourth derivative, it's going to be the same as the first derivative, that's cosine x. The sixth derivative is the derivative of cosine, which is minus sine. And then you can see the seventh derivative would be minus cosine, eighth derivative would be sine, etc. And then for cosine, we can just sort of look down here. The 0th derivative is cosine, it's just not taking the derivative, cosine x. The derivative of cosine x is minus sine x. We did that over here. The second derivative of cosine x is minus cosine x. The third derivative is going to be sine x. That's the derivative of minus cosine x. The fourth derivative is going to be itself again. So both of these functions, their second derivative is minus themselves, and their fourth derivative is themselves. So cosine x can be minus sine x and minus cosine x, and it's just gonna continue and repeat. So that is the derivatives of sine and cosine. And you can sort of think maybe this has some relationship to the function e to the x, and you will see that it does, but they both observe similar properties in that their fourth derivatives are themselves, and you'll actually see in a few videos what this similarity is. You can actually express sine and cosine in terms of e to the x, or specifically e to the ix. So we will see how that works, and I will see you in our next video on integrals. That's the other calculus operator.